Every day, new AI tools come into the market. And we have all different types and sorts of tools for different small use cases. If we want to generate an image, if we want to generate a video, if we want to summarize meeting contents, or for example, if we want AI to give us a proper study about a specific subject. So we have all these tools in the market that can help us solve these specific use cases. But what happens if we don't want to solve these specific use cases, but what we want to do is pick our daily operations, pick our more complex tasks, and understand how we can embed AI inside of them? How can we think about the different processes that we have? How can we break them down into smaller chunks, smaller tasks, and how can we evaluate what or which of these tasks can be better suited for AI? So in today's video, we are going to explore this concept of having different tasks, those different types of tasks. We are going also to check what type of tasks suit better AI or suit better human automation and AI. And we are going to end this showcasing how we can break a complex process into smaller tasks and how we can classify them so that we can improve and bring more efficiency into this process. Let's go. So let's start by asking a simple question. What is a task? And how can we define the type of task that we need to do? According to Deloitte, where they study 19,000 government US tasks, they came into the conclusion that there are 3 dimensions that can help them classifying the type of task. Those dimensions are first, creativity, difficulty, second, context variation, and third, precision. So according to them, all the tasks that we do in our different types of jobs and professions in the world, all those tasks can be put into somewhere in this triangle of the matrix between these 3 dimensions. So this means that it became more clear with this matrix, it becomes more clear who is the best, or from a human and from a machine, who is the best to perform a certain task. But then AI appeared, and AI did not appear just in the last 3 years, but already exists from the 80s, but evolved a lot in these last years. So let's see what happened from the beginning of AI until now. And to do this really quick, just to see how we can put this into the types of tasks. When the initial models of AI appeared, like linear regression, simple neural networks, we saw that despite the fact that they had some context variability, so they could a bit adapt into the environment, but they were still really close into the precision part. Their output was still, with more or less confidence, they were always a set of rules. But the more it started to increase the capacity and we started to have machine learning algorithms and finally these LLM models, and right now what we have nowadays with ChatGPT and all the other models that we see, is that the AI did a very huge jump from the precision sides of the matrix into more the creativity and the context adaptability. So GenAI became more suited for tasks that required context variability or creativity. And this is very important because so far machines had a very strict rule in the tasks that we need to perform. It was due to the fact that machines are really good in precision. They were put more into that side of the matrix, and then the rest would be for us humans. But with the come of LLMs or GenAI, finally, for the first time in history, we have a technology that resembles more to human behavior than to machine behavior. And this is very important because now we have a new role, a new set of tasks that can be performed by GenAI. Let's bring a very simple comparison between humans and GenAI. Of course, there are very big differences between both of them, but nowadays, both humans and GenAI can be somehow creative. Of course, we can challenge the idea of what is creativity, but let's not bring this for today. But both of them can be, in fact, creative. Also, both of them can adapt to the tasks that are required. Both of them can adapt to the context that is given. And also, they can be somehow precise. It's interesting because both humans and GenAI, they are not built for precisions. We are not good in being really precise. Also, GenAI. And it's interesting because it reminds me a bit about a saying in a famous movie in I, Robot, where Will Smith asks the robot if he can write a masterpiece, and the robot replies to him, "Can you?" So it's interesting because not humans nor GenAI can be really good in those tasks, but also on the average of humans, we are not also good on being really creative, on being really adaptive and precise. There is a whole scale of humans and people that behave differently on those characteristics. But now, evaluating also another point, let's talk about more the thinking process. So there is one thing called System 1 and System 2 thinking. We are going to talk a bit about those. But regarding the System 1, both humans and GenAI, they are good in implementing this type of thinking, System 1 thinking. But regarding System 2, humans still outperform way better GenAI. And what is this System 1 and System 2? So System 1 is the more irrational thinking that we have. We can call it the more instinctive thinking that we humans have. Normally, it's that first answer that comes into your mind when someone asks you something. You don't need to really process the information. You can simply reply to it immediately. And regarding the System 2, this is the moment where you stop to rationalize, when you stop to think and really deep dive into a problem. So this System 2 is that moment when you receive, for example, an email that you don't like, and instead of replying immediately with the System 1, you stop a bit and you think about the answer that you are going to give. You think about the reason why the person is saying what he is saying and what should be the best behavior that you should get. So this is the System 2. We can also compare a bit these two systems, for example, in the chess tournament, in the chess world, right? Where we can look into the normal chess play, that there is no time limit, and we can see that all the players, they do give a lot of time, a lot of thought process into the next move. But if we go to what it's called the speed chess, where players have a very limited amount of time to play, you can see that the game changes completely. So it's no longer a very rational game, but it's a very instinctive game. And most of the times it's not the most effective gameplay. So this is the System 1 and the System 2 thinking. So this process of doing a System 2 thought process, it's normally what it's called the tree of thoughts. So it's a sort of a tree where in our minds we are analyzing the different paths and we are deciding on which path to take. So this means that when we want to solve a task in our daily lives, any type of task, we might wonder, is this a simple task? Or is this in reality a complex task that needs to be broken into a tree? And for example, let's take posting a cat picture on Instagram. It might seem very easy nowadays for any person to put a cat picture on Instagram. But if we analyze what is happening behind, we see that is in reality a sequence of actions, because we need to go to the Instagram application, we need to search for the picture of the cat we want to put, because we might have a lot of them. We might decide to add filters or stickers or other types of enhancement of the image. And then finally, we post the image, and if we want, we can add some text on it. So in reality, the simple task of putting a cat picture on Instagram can be broken into smaller parts. And this is very important, because this is how we also should bring these complex processes into the game, and then we should break into smaller chunks. And this is very important, because this is the secret behind how you can embed AI tasks inside those processes. Because as you might remember, the fact that GenAI is still not quite good in system to thinking, it means that GenAI will not easily solve the tree of thought, the full tree of thought. He will be good for system one thinking, so he will be good for smaller, simple tasks that do not require a lot of reasoning. Of course, there are models nowadays that can do a certain type of reasoning, and it's good, and they will evolve. But regarding complex tasks in our daily activities that are very controlled, they are very stable, it's still better for us to break down this, control the steps, and then put AI where it needs to be put. So going back a bit into Deloitte's study, so according to them, on these 3 dimensions, we can put easily automation into the more precision part of the matrix. But then, how can we break GenAI tasks from human tasks? And nowadays there is a very big gray area, and every day that area is getting even bigger between the two of them. But the human nowadays, they are still better, and they still outperform every task that requires human interaction. For example, psychologists, any type of human interaction where we need to read the human body, we need to understand all type of communication that exists between humans, and also tasks that still require a very big reasoning capability. So a very large amount of organization work. But for the smaller tasks, GenAI can do better. And it's not a concept of better, because the effectiveness of that task can be challenged, but the fact that AI does not get tired, does not have an energy capacity or limitation to perform the tasks, it means that GenAI can, with time, he can perform more tasks without losing focus. And those are the good tasks that we can give to GenAI, because at first they are boring most of the times. So if we need to do a task that is not so complex, it's quite easy to do it, but we need to do it a lot of times, normally that task is boring. So for us, it's not a problem if we give them to GenAI. This way we can focus on the more challenging tasks, or in the tasks that require a more organization. So let's imagine here a use case. It's a bit of a technical use case, but it's a good one for us to analyze the different parts. So we have three types of tasks that can be done here. We have the human tasks, we have automation tasks, and we have GenAI tasks. So we can assume here that automation tasks are basically code, is deterministic code. The human, it's easy to explain, and the GenAI part is tasks that can be used or should be done by LLM model. So let's imagine we have the use case where we have one big database and we want to migrate that big database into another database. And one of the first things that we need to do when doing a migration project is what it's called the mapping, because the two databases, they are different. Most likely they have different tables with different attributes. So one very boring process that we need to do is the mapping. And the bigger the databases are, the more difficult it is to perform the mapping. So it would be interesting to see if we can bring a sort of accuracy and effectiveness in that process, mixing the tasks between the three actors here: human, GenAI, and automation. So let's assume for this use case that I already break down the tree of thoughts, or I already break the process of doing a mapping into the smaller parts. So we start normally by having, for example, I assumed here 2 Excel files with the schemas of both databases, where we have the names of the tables, the attributes, the description, etc. So our first task is to identify the tables in those schemas. After identifying, we can then pick the list and we can start doing the mapping. But because we are humans, we have a short memory limitation. So it's not possible for us to pick a list of 100, another list of 100, and from memory we connect them or map them. So in this case, what I normally would do, because it helps us to imagine what would a person do in this situation, is that I would pick these two huge lists and I would divide them in smaller groups of 10, for example, and on each one of those groups then it is easier for us to map. So we need to do this process where we pick groups of 10, we map them, and then when it comes to an end, we do this validation, because we are doing this analysis on the different groups of 10, so it's useful for us to do a validation of the mapping. And after doing this with the tables, we can do exactly the same thing with the attributes of those tables. So we can then go table by table. We can again fetch the attributes from the Excel, the two Excels, the source and the target, and we can select the groups of 10 and do the mapping on the attributes. After finalizing this, we then do again a validation just to check if everything is okay. Okay, so let's assume this process. Let's assume that we are going on this path. Okay, there are different ways to do a mapping between two databases, but let's assume that this is the path, or this was the tree of thoughts from this complex activity that is to map two databases. And that now let's go analyze the tasks. So let's start by the first one, identifying from the Excel files the name of the tables. And I'm assuming here that each type of database can have a different way of exporting a schema to an Excel. So it means that you can have different columns of the Excel with different names for the different columns. For example, you can have an Excel that has on the second position, on the second column, it has the column name, table name. But for example, you can have another Excel that has the tables in a column named entity name, and it is on the fourth or in the fifth position. So this means that there is the need to have some context editability here. So we can already remove from this equation the code or the automation part. So we have the human and the GenAI, right? But in here, if you guys see, we are talking about a very simple task that does not require reasoning, right? Because if you imagine, you can go to ChatGPT, you can give him the list of the columns that exist on that Excel, and you can say, hey, give me the name of the column where the tables are listed. And it is possible for him to do this because it's a small task and you give him the context. Okay, so yes, in this case, this first task can be done using GenAI. Now the next tasks, they are more easy because if you look at them, they are operations to be normally performed on a certain software or on a certain application. So we need to save those tables somewhere so that we can then pick them. And then we can start the process of doing a loop where we pick groups of 10, right? So that part also of the loop of fetching the next group of 10 can be done by automation. But now let's look into the mapping activity, right? The mapping subtask that we have here. So we have two groups of 10, right? The source tables and the target tables, and we need to perform a mapping between each one of them. And we can already remove also the automation part out of it because the mapping is not something that it's easy to be done automatically, right? Because in one database, you can have a table called delivery address, and on the target database, the same table is called address of delivery. So the two of them, for us humans, it's very easy to say that those two are the same tables, but for a machine, if you would simply put them one equal to the other, it wouldn't result. So automation is out of the question. Now let's look again into the GenAI versus human. We are talking about giving small lists, right? So imagine again that you go to ChatGPT and you say, here are 10 tables from the source, here are 10 tables from the target. Can you please do a map? And yes, he will be able to do this because it's a small list. So it means that this mapping process of this small group of 10 can be done using GenAI. So this whole loop part can be done automatically without the intervention of a human. Nevertheless, because this is quite a sensible topic to perform mappings, there might be situations where there are tables with very difficult names to reach out the context, right? There might be tables that a human simply knows it because he knows the client, he knows the business, so it's easy to identify, but it's hard for a generic GenAI model to understand. So for that reason, in my opinion, this validation step, this is a good task to be done by a human because it demands reasoning. He has to analyze the mappings and he needs to investigate on his own, on his mind, or even with other processes. He needs to do a reasoning on top of this mapping. So this is the first human task. Now, going to the attributes, the process is exactly the same thing. So the part of identifying the list of attributes from the Excels can be done by GenAI. Then the part of saving and fetching the groups of 10 can be done by automation. Finally, the mapping of the groups of 10 attributes can be also done by GenAI. So this full process can also be done automatically using automation and GenAI without human intervention. And finally, because again, mapping attributes can be a sensitive topic and it might need some more reasoning, capabilities to do a more effective job. This last task should be done by a human, the validating part. So you might see that with this analysis, it was possible to replace a complex task that was before done only by humans and could take weeks of work. It was possible to replace all with automated work and GenAI work, leaving only two validation tasks for the humans. And in this case, when I run this example in an application with two databases of 5,000 attributes each, after 10 hours of work, it was possible to reach 80% of mapping only done by code, by automation, and by GenAI. And in this case, the human just had to double check the work, and in this case, do the manual mapping of the remaining 20%. So it was possible to reduce hours or days of human work. So this is an example of how we can pick a complex task, we can break into the different tree of processes, and then we can evaluate task by task who is the better actor to perform this task, a human, GenAI, or automation, so that in the end we can bring more efficiency and a more cost reduction for this process. So let's recap here. We started by checking what a task is and the different types that exist. Then we talked a bit about GenAI and how it can differentiate from automation and from humans. And then we checked what is this concept of the system 2, or basically the complex tasks that can be broken into smaller chunks of tasks. And we picked a use case where we did this, and for each one of the tasks, we identify who was the best actor to do it, if it was a human, GenAI, or automation. And I hope that this example can help you evaluating the processes, the business processes that you do daily, and can help you find ways to improve it. Because we are not just talking about bringing more efficiency to the processes or reducing costs, but in general, we are also reducing the boring tasks on the human part. So we can leave the human side of the tasks. We can give more challenging tasks that can bring a better work condition. Let's put the boring tasks into automation or Gen AI. Thanks for watching. I will be continue doing more videos related with this topic. Feel free to comment or to advise or give ideas for next videos. Thanks a lot for seeing. See you next time.